Instead of being told exactly what to do in every situation, AI uses a set of rules called algorithms to learn from data and experience. This process often involves something called machine learning, which we will get into in a bit. Because it can learn, AI can get better over time, adapt to new informations, and handle complicated jobs. You can see AI in things like the smart personal assistant on your phone, like Siri or Google. When you ask it a question, it understands your words, finds the answers, and talks back to you. Another common example is how movie and music services suggest new things you might like based on what you've watched or listened before. Now that we just mentioned machine learning, what is that all about? Machine learning, or ML, is actually a subfield of AI. It focuses on teaching computers to learn from data without having to spell out every single step. Instead, the ML system finds patterns and examples and uses those patterns to make predictions and decisions. It's like learning by example, but the more data the system sees, the better it gets at a task. You can imagine trying to teach a computer to recognize pictures of cats. With traditional programming, you would have to write rules for every possible cat feature. That would take forever. But with machine learning, we feed the system loads of pictures labeled cat or not cat. The algorithm then adjusts its internal settings to correctly identify the patterns that make a cat, like pointy ears or whiskers. Over time, it learns to recognize cats in new pictures, even if it's not seen them before. ML is really useful for tasks that are complex and happen repeatedly. Think about email spam. They learn to recognize junk mail by looking at tons of emails marked as spam by the users. So it will work even when the spammers come up with new tricks and new email forms. Unluckily, some spammers are also not that stupid, so they figure out new ways to spam us. The question is, how do these machine learning systems actually learn? A lot of them use something called neural networks. Neural networks are a type of algorithm in machine learning that are inspired by how the human brain is structured. Think of them as layers of interconnected virtual neurons or nodes. Each neuron takes input, processes it, and passes the result to the next layer. Through these connections, neural networks can learn to recognize really complex patterns in data. Imagine these layers like a series of switches. The first layer takes raw data, like the pixels of an image. The middle layer works on that data step by step, finding important features. And the final layer gives you a result, like saying if the image is a cat or a dog. Neural networks learn by adjusting the strength of connections, called weights, between these neurons. If the network makes a mistake, it fine-tunes these weights to improve its future guesses. This is super powerful for things like image recognition. A neural network can learn to identify handwritten digits by seeing lots of examples. Now let's take neural networks a step further with deep learning. Deep learning is basically machine learning that uses neural networks with many layers. That's why it's called deep. Having lots of layers allows the computer to automatically discover very intricate patterns and features in large amount of data. It learns different levels of abstraction, building up from simple features to more complex ones. You can think back to the cat example. A deep learning system might have one layer that just detects edges. Another combines edges into shapes like eyes or ears, and even deeper layers that recognize a whole cat face. Because of this ability to analyze complex data, deep learning has led to big breakthroughs in AI, especially in areas like self-driving cars, which need to interpret lots of sensor data, and voice assistants like Alexa or Siri that might need to understand spoken language, which can get very difficult because people have different accents. A lot of people are not using English as their mother language, but still use Siri or Alexa with this language. Deep learning models often need huge amount of data to learn effectively. Now let's talk about how AI understands and works with human language. That's where natural language processing, or in short NLP, comes in. NLP is a branch of AI that deals with the interaction between computers and our natural languages, like English. It enables computers to understand, interpret, and even generate human language in a meaningful way. NLP combines ideas from language study, linguistics, and machine learning. It involves breaking down languages into parts, understanding the meaning of the words and sentences, and then potentially generating language to respond or translate. NLP relies heavily on machine learning models that have been trained on vast amount of text to learn the patterns of a language. This allows things like virtual assistants understanding your questions, language translations services like Google Translate, and even spam filters that understand the language used in junk mails. You might have heard about things like ChatGPT recently. These are examples of large language models, or LLMs. LLMs are super advanced AI systems trained on massive amount of text data. They learn the patterns, structure, and even some nuances of language, which allows them to generate text that sounds like very human-like. Think of them as models that can predict the most likely next words in a sentence based on the text they've been trained on. LLMs use a type of neural networks that really good at processing sequences of text. Because they've seen so much text, they can assist with things like drafting emails, writing code, summarizing documents, and answering your questions in a conversational way. While they're incredibly powerful, it's important to remember that they don't truly understand like human does. They're just very good at predicting words which come next. Examples of large language models are GPT-4 and Gemini, you may have heard. And also more coding relevant models like Anthropic Sonnet 3.7 is the newest model. And for ChatGPT, there are also reasoning models like O1, O1 Mini, and even O3 at the moment. Maybe a quick fun fact, there is no O2 model from OpenAI because there's a company in Germany which is called O2, and this is a conflict. So pretty funny. So they directly switched to O3 from O1. Okay, now let's talk about generative AI. This is where AI agents get really creative. Generative AI refers to AI systems that can create new content. This could be text, images, music, videos, or even computer code. So source code for a web app you might have seen on my channel. Unlike AI that just analyzes existing data, generative AI produces original outputs that didn't exist before. Generative AI uses machine learning models that have learned the patterns of a training dataset and can then produce new examples that follow those patterns. For example, large language models, like we just talked about, are a form of generative AI for text. There are also other techniques like generative adversarial networks for creating realistic images. I think a lot of you maybe tested this out with ChatGPT 4o at the moment. You get very impressive results. There are also other tools or AIs like Midjourney for images, and even ones for creating videos out of text. So yeah, you might have seen tools online where you can type a description and the AI generates an image based on that. That's generative AI in action. Artists are using these tools to create unique artwork, and they can even help with things like designing new products. Or as I said, implementing a web app for you or another software without knowing about programming at all. Sometimes though, even the most knowledgeable AI models don't have all the answers, especially when it comes to very specific or up-to-date informations. So they only have the status of the trained data, so they don't know what happened today in the news. That's where retrieval augmented generation, or in short RAG, comes in place. RAG is a technique that combines AI generative AI model with real-time information retrieval systems. Basically, when you ask the AI a question, it first looks up the relevant information from an external source like databases or just searching the internet with a browser, and then uses that information to generate a more accurate and informed answer for you. It's like giving the AI an open book exam. Instead of just relying on what it learned during the training, it can search for and use the exact information it needs. This is super useful for things like customer support systems that need to give you the latest product informations, or research assistants that need to refer to the most recent studies. RAG helps to make AI responses more reliable and reduces the chance of AI making things up. Now let's talk about AI agents. In the world of AI, an AI agent is a system that can act on its own to achieve a goal. Instead of waiting for single commands, an AI agent can make its own decision and take a series of actions to complete the task. It looks at its environment, decides what to do, and then takes action without needing step-by-step instructions for every move. You can think of it as an AI agent having a sense, think, and act cycle. It senses its environment or gets input. It thinks about what to do next based on its goals, and then it acts to change something or get closer into its goals. Imagine telling an AI agent to plan a dinner party for you. A capable agent could check your calendar, send invitations, search recipes, and even make a shopping list, all from that one request. AI agents are a step towards more interactive and self-sufficient AI. We've talked about how powerful AI models can be, especially large language models. But how do we actually get them to do what we want? That's where prompt engineering comes in. Prompt engineering is basically the skill of crafting the input text or instruction that you give to an AI model to get the best possible result. Because the AI generates its output based on the prompt it receives, how you ask a question or give it a task really affects the answer you get. For example, instead of just saying, "Tell me about dogs," a better prompt might be, give me 3 interesting facts about dogs that would be suitable for a children's book." Being very specific and providing context helps the AI give you a more targeted answer. You can even ask the AI to take on a role or give it an example of the format you want. Often it's an iterative process. You might try a prompt, see the result, and then tweak your prompt to get closer what you need. Speaking of prompting, here is a more casual and AI-assisted way of approaching programming called vibe coding. Instead of writing code line by line, with vibe coding, you describe what you want to code to do in plain language. And an AI coding assistant tries to generate the actual code for you. It's like explaining your idea to a really fast programmer who writes then the code. You won't get perfect results on the first go, but you can just iterate over it and tell the AI what to fix, what to add, and what doesn't work. So you might say something like, "I need a function that takes a list of numbers and returns the average." And the AI will try to write that code. Maybe you also want to provide the programming language for sure, so it has not to decide on its own in which language it should write this. You can then review and refine the code and can ask even to make changes or fix errors. It's a more interactive way to code, and it can help people who don't have a lot of coding experience or coding experience at all to create simple programs. You just need to be aware that you have to check everything. So it's not perfect. So at the moment, I would say it's more like a proof of concept. You can test things out or even write programs that are not need to be perfect. So they are not in an enterprise environment, and you maybe use them for your private stuff at your home. Finally, it's important to be aware of something called hallucination in AI context. This doesn't mean the AI is seeing things, but rather it refers to when an AI system generates an output that is incorrect or completely made up, but it presents it confidently in a way that is true. It's like the AI is guessing and sounding very sure of itself, even if it's wrong. This can happen because AI models learn patterns from data, but they don't have a true understanding of the world and the data. If they don't have the correct information, they might try to fill in the blanks with something that sounds plausible. For example, if you ask an AI who wrote a certain book, it might confidently give you the wrong author. So it's crucial to remember that AI isn't always right, and it's always a good idea to double check important informations. Techniques like RAG are helping to reduce the hallucinations by grounding answers in real-world data. So there you have it for today, a beginner's guide to some of the key concepts in the exciting world of AI. We've covered a lot from the basics of what is AI, how it learns, how it understands language, how it creates or can create new content, and even some of the challenges it brings. Remember, AI is constantly evolving, so keep exploring and learning. So there's nearly every day new stuff around AI. So if you found this video helpful, give a like, and if you also wonder what MCP is, take a look at this video.